So this one, there's actually a second window on my monitor currently. So imagine there are two views. This is called stereo neural inference. I don't know, is it showing the video now? I don't know if it's showing the screen share.
Yeah, it's just coming. Yeah, it's coming.
Okay.
Your face, yeah.
Yeah, so there should be two windows. So this is running off the right grayscale camera, and then there's a left grayscale as well. So this is showing stereo neural inference mode, or it would be if you could see both windows. So you can just see one, but it's running in parallel. So in this example, since it's running in parallel, you don't actually use the disparity depth, but you are running stereo neural inference. So you're doing disparity neural inference, if you will. So you're getting the right camera, which I'm showing here, and the left camera. You're getting where the face is, the bounding box, and then also the facial landmarks in real time. So that allows you to track the 3D position of objects that stereo depth algorithms fall apart on, like shiny objects, reflective objects, objects with extremely low visual interest, so just perfectly white or perfectly black things. And examples, this is a good example. You can see reflections on my glasses. Stereo depth would really struggle with that because it's matching features. And if there's this distorted reflection, it's not going to match properly, or if it does match, it'll match the reflection, which is then further away. But when you run the neural model in parallel, it's still finding my eyes pretty accurately. So you can